Hello, everybody. Welcome to the What's New in AI session. I'm Joana Carrasqueira, and I lead community in AI DevRel at Google.
Hi, I'm Erin Nardo, and I lead the Developer Journeys and Solutions Product Management team.
Woo! I love the energy. Well, in today's session, we'll go through the ecosystem of tools and APIs for developers who want to create and build new solutions with AI. From traditional machine learning models to generative AI, there's just so much that developers can accomplish with AI. And the machine learning world has completely changed in the past few years. So really excited to be talking about what's new in AI at Google with you all today. There's a lot of buzz around AI. Everyone's talking about it. There's many sessions at Cloud Next about AI. So let me just give you a little bit of a learning path throughout this conference. Today, we're going to talk about what's new. There are a few sessions in the afternoon about frameworks, solutions, and tomorrow there's a very special session about Gemma open models. There are fundamental questions that we need to be asking ourselves when we think about AI. And that's exactly why we're here today. How do we bring AI to everyone's developer's toolkit? How do we make sure that business leaders are equipped and understand the real potential of AI? And how can you affect the bottom line of your companies by leveraging AI tools and solutions? At Cloud Next, like I said, we'll be answering many of these questions. And we have a variety of talks to help you understand and learn new use cases and applications. In this session, we'll focus on what's new. We'll start by understanding how AI evolved from traditional machine learning models to large language models, and we'll do a deep dive on generative AI. Erin will then guide you through real-world applications and how to get started with the Gemini API, and we'll also talk about prompting and how to get involved in the community. Does it sound like a plan? Okay, I'm glad to see that you're still excited about today's session. So let's start with the AI ecosystem. At Google, our mission is to enable every developer to improve their products using machine learning. From free and open source frameworks like Keras and TensorFlow, to development tools like Colab and resources like Kaggle, all while ensuring responsible AI principles. And we are very committed to this, leading in an ethical and inclusive way. And Google is very unique in the way that we provide end-to-end solutions, because we have solutions across all the building blocks around the ML lifecycle. So regardless of your level, I'm sure that you're awake now. So Google's very unique in the way that we provide end-to-end solutions across the ML ecosystem, as you can tell. So we use machine learning extensively, our company, from internal tools that prevent food waste to products that have billions of users using it every day, like search and YouTube. So when we talk about machine learning, it's not just about the numeric computation, but it's really about the whole development lifecycle. From dealing with data, to creating and training models using growing frameworks like JAX, TensorFlow, or Keras, to deploying them to various surfaces, including mobile, IoT, microcontrollers, and WebML, and managing operating systems that use them. And all of this, as you can see in this slide, is underpinned by accelerated infrastructure for training and inference, and guidance to help you deliver the most responsible experience. We provide you tools that help you be responsible across the board. And we really believe that it's time for AI and machine learning to be a part of every developer's toolbox. So let's start with frameworks. Spoiler alert, we have some exciting news around JAX, Keras, and Gemma models. JAX is a great framework for generative AI. It is efficient, it's easy to scale, and it enables highly sophisticated optimization. We're excited to announce that we use multi-slice training to run an extremely large LLM distributed training job, and we were able to scale it successfully to almost ideal scaling. As an example, Google uses JAX for nearly all its research and generative AI development. Bard, which is now Gemini, and Gemma, that might be better. Bard, which is now Gemini, and Gemma open models were created using JAX. And as a former pharmaceutical scientist, one of the applications that I'm most excited about JAX is AlphaFold. Have you heard of AlphaFold? Any hands? Very good. So AlphaFold enables scientists to predict protein structures. Is a very good application that enables us to really understand and predict the protein's structures. Proteins are very important macronutrients that are part of our body, and they have many vital functions, but they are very difficult to predict. So by using AlphaFold, we were able to sequence around 20,000 proteins in the human body and almost 200 million structures. That means that we were able to catalog nearly all the proteins that exist and that are known to science. So this was really accelerated research versus taking so many years to just decode and understand the structure of one protein. So really big advancements that we are doing in the machine learning world through JAX. And huge kudos to the team at Carras. The Carras team, they went through a full rewrite, going from 135,000 lines of code to 45,000 lines of code. Carras 3 is multi-backend, and it allows you to run workflows on top of JAX, PyTorch, and TensorFlow. Carras 3 also includes Carras CV and Carras NLP for generative AI development. Carras CV and Carras NLP are the easiest way to develop state-of-the-art pre-trained models for text and image classification and object detection. And then lastly, Gemma. Gemma, you may have heard recently, we've just literally launched the Gemma open models. It's a new family of lightweight, state-of-the-art open models built with the same technology that we use to create Gemini models. I'm excited to share that Gemma is now available in the Carras NLP collection. And there's a session fully dedicated to Gemma tomorrow morning if you want to learn more. So, as we're here, you might be thinking, okay, it seems that just a few years ago, AI and ML was just a research project. So, how did it evolve so quickly and is used in so many cool applications nowadays? Well, some of you joining this session might be new to AI and may want to learn a little bit more about large language models. So let me just give you a very quick short overview. Large models, specifically generative AI, have fundamentally changed the industry in the past year. Everyone's talking about it, everyone wants to use it, everyone wants to use the businesses leveraging AI solutions. And it's not just the tech, it's the ease of access and the natural conversation style that we have with so many popular applications. So this shift, being able to talk in plain English with the model, has helped us solve many big problems. And in a variety of ways, many of us haven't even thought before, like taking notes during a meeting or maybe creating music through generative music. But even if large models don't solve all our problems, and most of our problems are still solved through traditional machine learning, and that's why I wanted to give you this quick overview at the beginning, it's important to understand all the underlying advancements behind generative AI. So I really like this slide, and I really wanted to bring it to you today, simply because it provides a great overview of how the technology evolved, from traditional programming to generative language models. So starting with traditional programming, and I promise that I won't move too much so my hair doesn't get in the way of the microphone, but traditional programming consisted of providing a specific set of instructions for a computer to execute. You had to know precisely which sequence of actions to follow to get from input to output. So you could teach the computer something like cat, type, animal, legs, for, fur, typically likes, cuddles, naps, and power. I mean, who doesn't? Then neural networks. They came in around 2012, more or less, and we trained AI models with a lot of data. So for example, pictures of animals, teaching the AI which ones were pictures of cats versus other animals. So cat, not cat. Is this a cat? Yes or no? Cat, not cat. So basically the model was able to perform a single task to solve a specific problem. And then this all evolved into large language models, and it's where we are nowadays. And machine learning algorithms can recognize, predict, and generate human languages. Large language models are normally pre-trained for multiple tasks on large corpus of text, followed by fine-tuning on a specific task. And those are really that's really the essence of this new paradigm that we see with generative language models. So large language models can also be called large models, which includes all type of data modality and generative AI, a model that produces content. For generative AI, computers not only learn from examples, but they can also use those examples to generate output. It works by feeding a large data set of text, images, or other data to an AI model, and then the model learns to identify patterns in the data using those patterns to generate new content, which is similar to the content that it was trained on. So when we take a look behind the scenes, as you can see, this technology has been around for a very long time, and that's exactly what this timeline suggests. But for the purpose of this session, I'm going to skip past 2017. I'm not going to bother with the whole story of it, and the introduction of transformers. So transformers are an architecture that was designed around the idea of attention, and as you can see, many models have quickly emerged, one after the other, powering incredible products at Google, from T5 to Lambda to Palm, Palm 2, Gemini, and now the Gemma open models. Now, when we think about large language models, it's not just about a single architecture. There are a number of underlying advancements across machine learning, software, hardware, but also the humans behind the technology. And it's easy to understand why this technology has experienced exponential growth. So, as large models are more accessible to everyone, we will see more and more applications emerging in the future. So when we think about these advancements beyond architecture, we really have to think about 4 key areas. And those are computational power, machine learning techniques, training data, and access to innovation. So we've been talking a lot about traditional machine learning, large models, and let's do a quick deep dive into generative AI. So what's generative AI? It's a type of AI that creates new content based on what it has learned from existing content. The process of learning from the existing content is called training the model, and this results in the creation of a statistical model. So when giving a prompt, generative AI uses the model to predict what an expected response might be. And this generates new content. It sounds simple, right? And generative AI is actually great at the following tasks. Let me read this very quickly for you. Creating and recommending content, powering conversational search and chatbots, scaling and automating workflow for repetitive tasks, using associate reasoning to find insights and relationships with documents and data, and generating coding and assisting developers in writing, explaining, and documenting code. All large language models evolved and will find new applications, just like AlphaFold, like I mentioned before, which has a really big impact in the scientific community. More and more applications will come up, especially from the community, from you, from the developers who work with this technology every single day. It's important to note that you can use generative AI in new and in existing applications. So you don't always have to come up with a new application for generative AI. Sometimes it can complement some of the existing applications in your development techniques. So, for example, it can be a part of a larger system, and then you can use deterministic programming beyond that. A large language model is a neural network that models the distribution of text on which it's trained. It can take input like it's raining cats and give the text word that is based on what it has seen in the training data. So a large model is almost like a very sophisticated autocomplete. A model trained on poetry will generate an output that's poetic. A model trained on code samples will produce output that's codey. And the current generation of large language models are trained on large, diverse data sets, representing all kinds of language and context from around the web. These models have billions, sometimes trillions of parameters, so they can capture language structures more complex than what we've seen previously, which makes them very useful for a number of common classical neural language problem tasks that we previously have trained specific models for those tasks, especially on entity extraction, classification, summarization, sentiment analysis, and translation. So now let's talk a little about a few things that make large language models different. They have a unique ability to let us prototype AI-driven applications really fast. Who's here interested in prototyping using AI? Okay, yes. Erin will solve your problems very shortly with a quick walkthrough. And I'm really glad to see that you came to the right place, because this is huge. Traditionally, building a machine learning powered app would mean that you would have to collect potentially thousands of examples for your domain, and then training and turning a model before you can start to evaluate or even explore its suitability. And this takes a lot of time and resources. So with large language models, we can actually start exploring an AI-powered idea in just a few minutes. It's very, very exciting. And sometimes you don't even need machine learning expertise. Multimodality. Multimodality is a future in generative AI and is extremely important because it allows a model to understand and generate content across multiple types of data, which can help humans solve even more problems, like the ones you have. You want to start prototyping using AI. So it, for example, can generate images from text descriptions or vice versa, as you can see in the picture. And it can also create content that integrates text, images, audio together all seamlessly. Welcome to the Gemini era. You might have heard these words before, but really, Gemini models are built from the ground up for multimodality. And I've just told you, multimodality is the future. Reasoning seamlessly across text, images, video, audio, and code. Today, there are 3 Gemini model sizes. Ultra, the most capable and largest model for the more complex tasks. Pro, the best model for scaling across a wide range of tasks. And Nano, the most efficient model for on-device tasks, which is available through an Android AI core. The Gemini ecosystem really has a flavor for everyone, depending on the type of problems that you're trying to solve. And as I mentioned before, we are excited to introduce Gemma Open models. They are responsible by design, and they have unmatched performance at size, meaning that sometimes the Gemma models achieve exceptional benchmark results, and they outperform some of the larger open models. That's really, really exciting. They're also TPU and GPU optimized. They have multi-framework support, seamless device compatibility, and model customization. And the best part, if you ask me, they empower community-driven innovation and collaboration, because only all together we can move the needle in the AI industry. We can find new applications and create applications that will have true impact in the world. And with that, I hand it over to Erin, who's going to guide you through some of these examples.
Thank you. All right, let's talk about how can you use this stuff? What can you practically apply it with? We're going to pick a real simple, real-world example to get started with. This is image accessibility, and we're going to leverage Gemini Pro Vision, and we're going to send multimodal payloads of image and text and get just a text reply back. This is going to allow us to read HTML pages, parse through those pages for the images, and locate those images that don't have alt text, and then we'll use Gemini to provide that text for us and get it into the HTML. So let's get started with it. First, we would start by installing the SDK, and then we'll create a very basic script. Magic of being on screen and on stage, this happens seamlessly as you see it, to execute our API calls. Once we do that, we're going to start attaching an image and making sure that we're communicating with the model. We'll first load that image into JavaScript and encode it into base64, and we will start with this image of our sleeping cat. Once we have the image loaded, we can start to leverage it as an input to that prompt, and when we rerun the script towards the bottom of the screen, it should give us something like this, where it says that Gemini basically sees that there's a cat sleeping in the grass. So now that we know that everything is communicating successfully with the API, we'll adapt our script to read the local HTML file, parse it for the images, and add those alt text attributes that we're missing from the flags and get those in the HTML file. So next time someone views that web page and is looking for the image alt text, someone who might have some site limitations, they'll be able to get more details on those pictures. So we've just taken a step forward in making the web even more accessible by using Gen AI without having to spend all the time to come up with those tags ourselves. So that one's pretty simple from an example. Let's talk about some other ways that we've seen it used in healthcare. One is to help your clinicians spend more time with their patients by automating some of those heavy repetitive tasks that they need to do over and over again. It can also be helpful from a customer service perspective because it can help summarize and locate and provide those details about your plan, benefits, and help you get your appointment booked, all those things that I'm sure all of us have done and have found difficult, and now Gen AI is making that easier for all of us as consumers. And as Joanna mentioned a little bit earlier, accelerating the development of drugs through faster protein predictions. And so we're going to take a little bit deeper dive on that one next. So in this use case model, AlphaFold was used to help with protein prediction to support drug development. And this was really helpful for the organization that was doing that because it helped them get to market faster because it allowed them to train and run those experiments and scale, and that they were able to get their costs optimized and ensure that everything was ready operationally to get to market and bring those drugs forward. This is an example of the architecture that was used to implement that use case. And you can see it included the Vertex AI pipelines were used to support the feature preprocessing, the model inference, and the structure relaxation pieces, as well as a number of other cloud components as well. In financial services, some other examples that have seen this used is tailoring content and marketing offers to the users to scale and drive growth. They've also used it to identify and summarize contents of documentation to help improve efficiency, and we'll take a look at a use case that does that next. And it can also help translate those regulatory and business requirements into code, and that will really help you manage some of your risks and ensure that you're staying compliant. So if we look at this use case for capital markets research, in this case, it was an investment firm that needed to read basically a lot of information to come up with some insights and actionable next steps that they could do from their investment perspective. So this was helpful for the employees because it was able to more efficiently provide the summaries. It was also provided them much more better return because the insights that were generated were actionable right away. So it reduced that time there, as well as by being able to leverage technology to do that, it reduced the risk of errors and inaccurate summaries that could be put together because, as we know, humans make mistakes. So this is an example of how the use case was implemented here as well. You'll see a lot of cloud products in this one as well. And the Vertex Enterprise Search was used to enable that AI-enabled search and summarization in this use case. Let's talk about retail. So some of the ways that we've seen it used in retail is generating image and copy for your product catalogs, as well as being able to leverage a chat interface to answer customers while they're shopping or to provide a more conversational experience, and we'll take a look at a use case around that, as well as to be able to help the customer service reps when they are dealing with a complex question from an end user by summarizing and synthesizing data sets both internal to that organization as well as external to get those answers better and quicker for those users when they're calling in. And in this case, the use case, we used AI to provide a personalized search and contextual conversation experience in real time. So you can see like the example there where someone's looking for a bike that they can use on a day-to-day basis as well as for triathlons. And the benefit that the organization saw about providing these experiences is it helped them drive sales because it improved their conversion rates. They often saw larger shopping carts and larger orders, as well as it improved the customer retention because you got your customers the right thing the first time that they needed it. And here is how this use case was implemented. You can see a number of components in this. And so Enterprise Search provided the AI-enabled search capabilities along with conversational AI to allow the chat-like interactions and responses. And the recommender engine was used to order those responses back to the user based on their own preferences and previous interactions with the site, so making it more tailored for them. You also see a number of other cloud products as well that I know all have sessions or have booths that you can learn more about there. But now that we have looked at what you can do, let's get you started. So one of the first things you can do is to visit aistudio.google.com. This is a very easy way to get started with generating your API keys. You can create and test some of your prompts. You can customize your models, as well as generate some starter code. So this is Google AI Studio. It's a web interface to the Gemini API that you can use to quickly get started on your ideas without needing to write any code. So it's very approachable even if you haven't done any of this before. I'm not a developer at heart, and I've been in there and found it very easy to get started with. So the first thing that you're going to do is start with getting your API key, as you can see in the upper corner. Then we're going to select our model. In this case, we're using Gemini Pro Vision again. And then you can provide your prompt by asking the model something you want to do in natural language. In this case, we've provided 3 images and asked it for a meal plan based on what it sees in those images. So once you start to see it working as you desire, so once it's starting to look good, you can now go get your starter code, and you can select what language you want that starter code in, so there's a number of options for you. And then you can also get help from AI Studio with being able to embed this into your own application, including with creating a Colab notebook that is already pre-filled with your prompts and the settings that you had been prototyping with. You can also just interact via the SDK and go to ai.google.dev to get that. And so this is a REST API, so you can interact with it directly, or you can also work with it via the client libraries that are listed here, as well as Go and Flutter, which we don't have listed on the screen today. And while we've talked a lot of very centric around developers, we also want to recognize, for those of you who are interested at the enterprise level, that Gemini is also available in Vertex AI on Google Cloud, and it is can access Gemini as well as a number of other models, and so it's got some of those enterprise level support and things that you may need as you continue to grow or look to move to production. We also have information here on how you can migrate to cloud, so you could get started in AI Studio or with the SDK directly, and then if you find that it makes sense that you need to move to the cloud and get a more enterprise-ready level, you can move into Vertex. Or if you're already cloud native, you could go ahead and get started with Vertex directly. So then I will turn it back over to Joana to close us out on some prompting and community bits.
All right. So the best place to start is with simple text prompts. You can start off with a simple creative prompt, and the model will happily give you a poem with many verses rhyming. And this example went on for a little bit, but I've saved you from most of it. This makes a nice example, but in practice, you aren't likely to do something that it's this simple. So let's imagine that we want to send a tip with our daily JavaScript newsletter. Here we've used basic instruction prompt with just some extra guidance. Not bad. One issue with this kind of prompt is that when you always use the same input prompt, you're going to see repeated outputs very quickly. While you can request some diversity and creativity through the model settings, for example, on temperature and number of outputs, it will buy you a little runway, but for this example, we really want a unique output forever. So this time, we've added examples. We call this a few shot prompt, and as we give the model a few examples of what the input-output should look like, it continues the pattern. Technically, this is a one-shot prompt, and we only have one example. We leave the prompt hanging at the end so that the model will continue exactly at this point, generating the tip itself. And here's how it looks like in AI Studio, where it's called a structured prompt. Another subtle difference with this prompt example is that each output is conditioned on a topic, as you can see, and it does mean I need to provide a topic to generate a tip. or have it suggest topics based on your newsletter content, for example. Topics are also much easier to deduplicate programmatically than the entire tips. And here's the basic text interface in Python. And then here's the chat interface. Chat as conversational state. So if you're making raw API calls, you'll need to manage that yourself. If you use the SDKs like we have it here, it's taken care for you. This has benefits. It means that you can save and basically resume conversations and even edit your history if you have to. And then lastly, just wanted to give you some pointers on where to go after this session in terms of finding more resources, how to get started, and finding a community of support. The first one is Colab. Colab is always a great resource to start programming in Python, and it's getting even better with more advancements in AI. The second one is Kaggle. If you want to get started, the Kaggle community is the most welcoming home for machine learning and data science. So, and really the work of this global community is critical to the future of AI, because only with a large community we can really stress test all these applications that we're trying to build. We also have many competitions that you can join individually or as a group, so just check it out. It has some really nice ways on how to get involved with the community. And then lastly, Build with Google AI. ai.google/build is a really great place for you to understand some of the developer journeys, use cases, some of the applications that Erin also mentioned before, but also if you go to YouTube, you will be able to find on Google Developers YouTube channel a series of Build with Google AI videos. Joe Fernandez, he's also speaking at this conference, so I highly recommend you joining his session this afternoon. He has a series of videos on how to get started with the Gemini API. He has some cool deep dives and applications that you can follow through. So 2 resources that I highly recommend you to check out after this session. Thank you so much for staying with us today. I hope that you enjoyed this overview and this guidance from traditional programming, from traditional machine learning, and how it has all evolved into generative AI. I know that we are seeing new paradigms and a huge shift in the industry. If you have questions, if you have case studies, applications, anything that you'd like to chat with us about, our team is going to be at the Innovators Hive at the AI and the Kaggle booth. So come chat with us, ask us any questions. We're here to support you. Would love to hear what you're trying to build with AI, pain points, and things that you're trying to do. So come hang out with us. We'll be here for the entire conference. So I think up next, are you ready to build what's next? These are the slides that you will see at every single session, but just recommend you to scan the QR code, leave us some feedback about the conference, about the sessions, and what would you like to see in future events. I hope you enjoy Next. I hope you enjoy the AI learning pathways that we prepared for you at Next, and come chat with us. Thank you so much. Thank you, Erin.